This video is for educational purposes only. It is not sponsored, endorsed, or affiliated with any brands or manufacturers featured. All products shown in this video are owned by me, and any trademarks visible are part of the product being analyzed. In Chapter 1, Episode 7, we will learn about MCB curve types. First, we will list the common and general MCB curve types. Second, we will do a comparison between them. Third, we will identify the curve from MCB examples. Previously in Episode 6, we have learned about MCB curve characteristics and mentioned that IN is the thermal current rating of the MCB, and the MCB curve has two zones. The first zone is for thermal long-time protection, and the second zone is for magnetic short-time instantaneous protection. Current in Zone 1 will force thermal tripping. Current in Zone 2 will force magnetic tripping. Current before Zone 1 will lead to no tripping, and current after Zone 2 will force magnetic tripping but at risk of MCB damage, depending on the intensity of the fault, and how much the MCB can handle high-intensity faults. Now let's learn about MCB curve variations, and start with curve Z. This curve example has rated current IN equal to 10 amperes and general magnetic settings 2 to 3 times the value of the rated current IN. This gives us magnetic settings between 20 amperes and 30 amperes. We also have curve B. This curve example has rated current IN equal to 10 amperes and general magnetic settings 3 to 5 times the value of the rated current IN. This gives us magnetic settings between 30 amperes and 50 amperes. We also have curve C. This curve example has rated current IN equal to 10 amperes and general magnetic settings 5 to 10 times the value of the rated current IN. This gives us magnetic settings between 50 amperes and 100 amperes. We also have curve D. This curve example has rated current IN equal to 10 amperes and general magnetic settings 10 to 20 times the value of the rated current IN. This gives us magnetic settings between 100 amperes and 200 amperes. Now let's compare these mentioned curves side by side. Generally speaking, we can see that curve Z trips magnetically between 20 and 30 amperes, and curve D trips magnetically between 100 and 200 amperes. This means that curve Z is the fastest and most sensitive to magnetic tripping, while curve D is the slowest and least sensitive to magnetic tripping. Curve B is slower than curve Z and faster than curve C, and curve C is slower than curve B and faster than curve D. Creating this content takes a lot of time, effort, and experience. Support us by subscribing and liking the video. It helps us keep producing free, high-quality information for you and others. And if you have any technical question, feel free to ask us in the description, and we will provide you with the answer. Now let's summarize and list the common MCB curves and specify their applications. As mentioned before, curve Z is the most sensitive, suitable for very low inrush current applications, like precision and sensitive electronics. Curve B is less sensitive than curve Z, suitable for low inrush current applications in residential and light commercial loads like homes and offices. Curve C has medium sensitivity, suitable for medium inrush current applications like general residential and commercial loads. Curve D has low sensitivity, suitable for high inrush current applications in heavy, inductive loads like large motors, welders, and transformers. We also have curve K. This curve has medium to low sensitivity, suitable for medium to high inrush current applications in some inductive loads, like medium motors, welders, and transformers. So curves can be defined by the magnetic trip settings, which is the minimum and the maximum magnetic values. Between this range, the breaker must trip instantaneously, depending on the tolerance, temperature, age of the breaker, and all surrounding conditions. Above the maximum magnetic value, the breaker must trip ensuring protection. To better understand this, let's take example curve C having magnetic settings 5 to 10 times IN, and IN equal to 10 amperes. At 4.9 times IN, the breaker won't trip magnetically, it will trip thermally if the conditions were right. At 5.1 times IN, the breaker might trip magnetically depending on the conditions. At 10 times IN, the breaker must trip instantaneously. And at 12 times IN, the breaker will absolutely trip instantaneously. The magnetic setting selection also allows inductive loads, like motors, to have startup inrush current below the minimum magnetic value, keeping it outside the magnetic range to avoid unwanted tripping. In other words, since the inrush current is fast, and being in the thermal range that is responsible for the long-time protection, the breaker will not trip instantaneously. If the startup inrush of the motor is within the magnetic range, the breaker will be a nuisance tripping. Now we can say that the magnetic trip settings help us to define the manufacturer's tolerance range. Testing and certification standardization prevents overstressing the breaker mechanism, time-current coordination, helps with inrush management, and avoiding nuisance trips. Now let's determine the curve of the MCB. It is simply printed on the breaker, so this breaker is curve C, and this one is curve B, and this one is curve D. In the next episode, we will learn about MCB curve plotting. We will plot ampere values on MCB curves and analyze the data.